times. Okay, good afternoon class. So at this point we're looking at the second, I think this is the second video on dealing with our paper 2 that you guys have written last term. Okay. So we're just wrapping this up here for you to see what the issues are for future students to benefit from the video. You don't say that. Okay, so in question 5 we are told, given circle center G, points A, O and C lies the circumference of the circle, then we are told that OA is equal to OB, which is equal to 2 root 13. Then we are told that BOC is a straight line. The first question says, find the x coordinate of A. Find the x coordinate of A. So what we have here, since we have the distance of AO, I'm going to go with distance formula. So AO squared is equal to the square root of x minus 0 squared plus y minus, no, it's not y is 6. Not so. So AO squared is equal to this AO. If I'm going to put square, then I must cancel the square root, which I don't want to also do. So it's going to be x minus 0 squared plus y minus, no, 6 minus 0 squared. Okay? But AO is 2 root 13 is equal to the square root of x squared plus 36. Okay. Now I'm going to get rid of the square root, so I'm going to square both sides. So it's going to be 13 times 4 is 52 is equal to x squared plus 36. So x squared of course is equal to 52 minus 36, which is 16. Is that correct? So x is equal to plus minus 4. So therefore x has to be 4. Why is x 4? Because it lies in the first quadrant. Okay. So any confusion there? Okay, the lining of this board is just trying to sort it out. Okay, so x is equal to 4. Alright, let's go with the next one. 5.2. Let's pull this up here. 5.2, 5.3. So 5.2 says, determine the equation of the circle center D if A is 4 and 6. So that now also confirms what my A value is, my x value for A. Okay. So 5.2. And again people, if you guys got a different value for x in 5.1, don't use your wrong value. Or don't use the value you think it's right. Use the value given. Because if you use anything else, even if you are right, and you don't use the value given here, you can't get positive marking there. Okay, so you're not using information given. Okay. So we are told that x is 4 in this case. So determine the equation of the circle. So that will be x minus a squared plus y minus b squared is equal to r squared. Now D is the center of the circle, so those lengths are equal. Okay, so I'm going to work out the coordinates of D. So D will be x1 plus x2 over 2, as it's the midpoint, y1 plus y2 over 2. So D works out to be 4 plus 0 over 2 and 6 plus 0 over 2. So D works out to be 2 and 3. Alright, so since the length of the diameter is 2 root 13, so the radius has to be half of that. So 2 root 13 divided by 2 is just going to be root 13. Therefore, the equation reads x minus 2 squared plus y minus 3 squared is equal to r squared, which is the root of 13 all squared, which is 13. Okay. Let's go to the next one. If the area of triangle AOB is 13 units squared, determine with reason the size of OAC. OAC. So this angle here we need to calculate. People, I know that C is 90 degrees, not so. Okay? So, when you work out the area of a triangle, let's just see which triangle is given here. It's AOC. The triangle's area is given. How do we calculate the area of a triangle? So half base times perpendicular height, it's a right angle triangle. Is this a right angle triangle? No. A non-right angle triangle, I must use the sine rule. Not the sine, the area rule, sorry. How do we calculate the area rule? It's half AB sine C, where the angle is the included angle. Okay. So when we're using the sine rule here, now 5.3. So the area is going to be a half. In this case, it's going to be BO times AO sine of angle BOA. Okay. So I'm going to pull this over. Can you see we've got these two lengths and an included angles? Can you see that, people? So the area of this triangle, as we said, is 13 is equal to a half times BO, which is 2 root 13, times AO, which is 2 root 13, sine of BOA. Okay? Root 13 times root 13 is 13. I divide both sides by 13. So that will cancel. And the 2 here. So I'll get a half is equal to sine of BOA. As we know, that's a special angle. So the angle of BOA, of course, is going to be 30 degrees. Okay? However, as you can see, this is an obtuse angle here, not so. So this is only a reference angle. This is one of those cases where it's an obtuse angle. Can you see that, people? So therefore, the size of BOA is simply 180 minus 30, which is 150 degrees, which is this angle here. Alright. Then we know that this is a straight line, and given a straight line there, so that angle is going to be 30 degrees. So AOC is equal to 180 minus 30, which 150, sorry, which is 30 degrees, and its angles on the straight line there. Remember, this is the angle they want. Okay? So now we know that angle C is 90 degrees. Why is angle C 90 degrees? Because it's angled in semicircle. So therefore, angle AOAC is going to be 180 minus 90 minus 30 degrees, which is simply 60 degrees. And the reason here is sum of triangles. People, there's a reason here. We don't need these reasons here. Why? So we're not busy with Euclidean geometry. And neither did the question say. No, it did say with reason. So just we have to then give our reasons then. Okay, I thought they didn't say with reason. If they did not specify with reason, then you didn't need to give the reason here in this case. Okay? But because it's specified with reason, there was marks allocated for the reason. Okay? Let's go to question 6. 5 marks. 6.1, it says show that. 6.1. It says show that sine of 540 minus x times sine of minus x minus sine 90 plus x times cos of 180 minus x is equal to cos 2x. Of course, the left hand side would be the easier one to work with. So what do we notice here? We can reduce this first and see what happens. But take minus 360, I get 180, is that correct? So that is going to be sine of 180 minus x. I could have gone and said the sine of x straight away, no? This I could add 360 to it, well I know it's in the fourth quadrant, so it's just negative sine x. But if you didn't know that, no problem, it's going to be sine of 360 minus x minus 90 plus x. Which quadrant is that in? 90 plus x is in quadrant 2. We sign positive and negative? Positive. But it changes to cos x. Okay? 180 minus, which quadrant is that in? Second quadrant. Is cos positive and negative? Negative cos x. Okay? So let's simplify. It's going to give you sine x times negative sine x minus plus cos squared x. So sine x times negative sine x is negative sine squared x plus cos squared x, which is the same as cos squared x minus sine squared x. And what is cos squared x minus sine squared x equal to? Cos 2x, which is equal to the right hand side. Okay. (6.2) It says hence finds a general solution to. But now remember that this here, sine 540 minus x times sine of minus x minus sine 90 plus x times cos of 180 minus x. This whole thing is in fact equal to cos of 2x. So cos 2x is equal to negative 1. Okay. So let's draw the cos 2x graph. This is what the cos x graph looks like at 360. But what effect does the 2 have on the graph? Divides the period in half. Not so. So this is simply going to be 180 here. So where's sine minus 1? Where's cos of x equal to negative 1? At this point, which is? What's the value here? 90 degrees. Okay. And this is happening every how many degrees? 180 degrees. Can you see that? So here we say that x is equal to 90 degrees plus k times 180. We k is an element of integers. That's one way of looking at it. Okay. Otherwise, if you go with cos of 2x is equal to negative 1, I didn't say my reference angle there. My reference 2x, I draw my cos graph, and we know that if that is 360, that's going to be 180. So it's going to be 2x is equal to 180 degrees plus k times 360. As we know, the period on the tan graph is 360. Divided by 2, so x is equal to 90 plus k times 180, where k is an element of integers. Either way is going to get you a full 3 marks. Okay. (6.3) Prove the identity. Of course, left and right hand side story here. I'm going to work with my left hand side first. People tan can be written as sin theta over cos theta plus cos theta over sin theta. Okay. So what's my LCM here? Sin x cos x. Or sin theta cos theta. So what must this be multiplied by? sine theta. So it's going to give you sine square theta. What must this be multiplied by? Cos theta. So cos theta times cos theta, cos square theta. And what is sine square theta plus cos square theta? 1 over sine theta cos theta. But what do you notice? It's not the same. So one of two things can happen. I can either multiply numerator and denominator by 2 and then make it look like the right hand side, or you can work with the right hand side and say, okay, what can happen to sine 2x, sine 2 theta? It can be written as 2 sine theta cos theta. So what's going to happen here? Cancels. Leaves you with 1 over sine theta cos theta. Therefore the right hand side equals left hand side. You guys understand? For those of you who wanted to see the other side of this here, you multiply 2 over 2, which gives you 2 over 2 sine x cos sine theta cos theta. So 2 sine theta cos theta is sine 2 theta. So it's 2 over sine 2 theta, which is also equal to the right hand side. So whichever way you want to do, you'll get the full mark either way. Okay. For question 7, simplify without the use of a calculator and showing all steps. So firstly I'm going to reduce all this to acute angles. So that is going to be, which quadrant is 124 for the second quadrant? So it's 180 minus, sorry, 36, 56. Okay, times cos of 64. So I'm going to keep 64 and change the other one. Okay, also I'll try and pick up 56 minus sine. Which quadrant is 214 in? Quadrant 3. So it's going to be 180 plus some value, so it's 214 minus 180. Doesn't involve 54. So what I do is I say, okay, also to get into the third quadrant, it could be 270 minus something. Let's say 270 minus 56. Can you see that? So it's going to be 270 minus 56 times, now you see it's 26. So what do I say here? Cos of 90 minus 64. Okay. You say 90 minus 64, it should be 26, yes. Okay, why do I choose 26? So that I can reduce this under the compound angles identity. Okay. So let's go. You say, okay, it's all stations to Claremont diagram. 180 minus 56 takes to the second quadrant side is positive, so it's sine 56 times. Cos of 64, we didn't do any change there. Okay, so then this will be cos 64. Remember, under 90 and 270, the co-function is applied, the co-ratio. So that is 270. Let me just check here something. Alright, so that is 270. So 270 minus takes you into the third quadrant. And sign is positive and negative in this quadrant. Negative, making this negative a positive. So it's positive cos 56. 90 minus takes you into quadrant 1. Is cos positive and negative? Positive, but changes to sine 62. Sine cos sine, which expansion is this? The sine compound angle is, so it's going to be sine 56 plus 64. Not so. The sign is going to have the same sign. Okay? And now my girl, you're sitting in broad daylight, you're playing on your phone, you're not even taking note of this. Come on, my girl. Did you get 100% for the section or what? Then leave the guys. Or the girls. Jesus. 56 plus 64 is 120. So you go sine of 120, which is the same as sine 180 minus 60, which is in the second quadrant. Sine is positive. Sine 60. And that now comes from the special angles here. 30, so it's 1 to root 3. The sine of 60 is the root 3 over. Okay. When it comes to the special angles, people, make it a habit of writing down the special angle. Okay. People, if Q is equal to the sine of 35, write cos of 70 over sine of 325 in terms of Q. So of course I must relate every angle to 35 degrees. We know that 2 times 35 is 75. 70, sorry. So it's going to become cos 2 times 35 over. Now sine 325 can be written as sine 360 minus 35. Okay. So 360 minus, there's all stations to Claremont, it takes you to the fourth quadrant. Sine is negative in this quadrant here. Okay. So it's going to be negative sine 35 in the numerator. Cos of 35, cos 2 theta can be written as 1 of 3. So cos 2 theta can be written as 2 cos squared theta minus 1, 1 minus 2 sine squared theta, and cos squared theta minus sine squared theta. Which one are we going to use? The second one. Why? Because why? It can be in terms of sine. So it's 1 minus 2 sine squared 35. Remember what is sine? Q. So it's 1 minus 2q squared over negative q. Or the equivalent answer, which is 2q squared minus 1 over q. Okay. Let's carry on. Solve for alpha. If 2 cos 2 alpha plus 5 cos alpha is equal to 4, where alpha is an element of negative 360 to negative 90 to 360. Alright, so if you look at this here, of course you're going to land up with a trinomial. Okay, so which one of the three am I going to use here? It has to be the first one. Why? Because of that is cos. People, if that there was 5 sine alpha, then I would have chosen the second one. Why? So that I can again form a trinomial. Okay, or if this was cos alpha sine alpha, then I would have opted for the third one. Okay, so that the trinomial can also be applied there, factorized. Okay, so as I said, I'm going with the first one. So you got 2 cos squared alpha minus 1 plus 5 cos alpha equals 4. Get rid of the bracket. So it's 4 cos alpha squared minus 2 plus 5 cos alpha minus 4 is equal to 0. So we've got 4 cos squared alpha plus 5 cos alpha minus 6 is equal to 0. Okay, now this becomes a trinomial to us. Okay, so we got 4, 5 and negative 6. Give you 3 over 4. So cos alpha is equal to 3 over 4. Or cos of alpha is equal to a negative 2. Okay. Now if you use the quadratic formula or you're using this calculator, you don't have to put this roots in here, in this brackets.
You don't have to write it down either. Because there is no mark allocated for this. Okay? But for those of you who worked it out, this is what you should have had in that bracket. Okay? Yes, Michael?
So how do you work that out?
How do you mean?
Like without a calculator?
Then you must know the rules of trinomials, because this is 4x squared plus 5x minus 6. Do you remember this in grade 9 and grade 10? This is basically what we are using here. Your trinomial factorization. Okay. But what we do is we use the quadratic formula. Okay. But if you don't know how to use that trinomial factorization, use the quadratic formula. It works all the time. Okay. But coming back to the question here, we are asked whether alpha is an element of negative 90 to 360. Okay, so we got arc cos. We got arc cos of negative 2. So we got arc cos of negative 2. That gives you an error because that's outside the given domain. So that one is no solution on it. Okay. However, the other one, your reference alpha angle, so reference alpha is equal to arc cos of 3 over 4. Gives you 41,4. 41,41 degrees. Okay. Now coming to the restricted domain. Alright, so firstly, where is cos positive? Cos is positive in quadrant 1 and quadrant 4. So let's go with quadrant 1. It will be alpha is equal to 41.41 plus k times 360, as the period on the cos graph is 360. Or quadrant 4. How do we get in quadrant 4? You got alpha is equal to 360 minus 41,41. Gives you a 318. 318.59 plus k times 360. K is an element of integers, not needed here because our final answer is not in that format, but safer for you to write it. K is an element of integers. So what do I say? So now we need to list. So alpha is an element of. So we go with the first branch. We put 0 where we see k. We get 41,41. And that is within the given domain here. If I'm going to go with k being 2, or 1, sorry, it will give you a value over 360, which I'm not interested in. And if we say 41,41 minus 360 is also a value far lower than negative 90, which I'm also not interested in. So let's go to the other branch. If I put 0 in k here, I'm going to get 318,59. 318.59. Okay. And if I put minus 1 in here, I'm going to get an answer of negative 41,41. If I put minus 2 in, of course it will be a value far less than negative 90. Okay. That gives you an answer for 7 marks there. Question 7.3. People definitely always get the sum like that, your general solution sign. 7.4. In the diagram below, two functions f and g are shown. F is equal to sine x. So here f of x is equal to sine of px, whilst g of x is equal to q sine cos x. For x is an element of negative 180 to 180. Okay? Let's get the questions here quickly. Alright, so let's look at the first question. Number 1. Write down the value of P. So if you look at the graph or the equation, P is in front of X. And what effect does P have on the graph? There's a period change on the graph. The sine graph is normally 360 under normal circumstances if the coefficient of X is 1. But since the coefficient of X is P, I need to see what the period of the sine graph is. So where's F? F is this graph here. So if I draw the normal sine graph, that's what the graph looks like in 360. So yes, it starts at 0, and this point here, which is normally 90, is at 180. So the graph is actually stretched horizontally. Okay? Which means to say that value has to be less than 1. Okay, so therefore P is equal to that point is normally at 90, but now at 180. So your P value is a half. And we can test the graph as well. Okay, if we draw the graph, that is the normal sine graph at 360, but because of that half is going to be 720. And this has to be 360. And that has to be 180. Okay, on the sine of X graph. Okay, so that's that. Let's look at number 2. The Q value. Now the Q is to do with the amplitude of the graph. From the neutral to the maximum is your amplitude. So that's your neutral here. Your maximum is 2. What is that distance? 2. So what's the value of Q? 2. Okay. Is that an inverted graph? Is the graph first going down then up? Yes. Can you see that, people? Because if I draw the normal cos graph, start at its maximum and go to the minimum. So if that was 2 and minus 2, then the amplitude or your Q value would have been 2. But because the graph is starting at its minimum and going up to its maximum, this graph has to be negative because that's inverted, inverse, the inverse graph. Okay? It's reflected in the x-axis, sorry, not inverse, okay? So your Q value is going to be minus 2. What's the amplitude of G? The amplitude of G is 2. Remember, amplitude is never negative. What's the amplitude? It's a measurement from your neutral to your maximum. That's your amplitude. Okay? Number 4. The period of h of x, if h of x is equal to, so h of x is equal to sine 4px. Okay? The period. So what I need to know is, I need to know what number is in front of x to decide what the period is. Okay? So I know what my p value is half. So it's sine 4 times half x, which is the same as sine of 2x. So what is the period of the h of x graph? 180. Therefore the period is equal to 180 degrees. Okay. Okay, the next question. 7.4.5. If j of x, let's just take this off here. If j of x is equal to sine of px plus k, for which values of k, where k is greater than 0, which means to say k is positive, will the function g and j never intersect? So what is the graph of g of x? The graph of g of x was 2, negative 2, cos x. Okay. So if you're looking at the sine of x graph, this part of the graph is actually f of x. Can you see that before? That's actually f of x. What effect does k have on f of x? To get j of x. What effect does k have on f to get j? So horizontal shift. The graph is either moving up or down. Not so normally. But because k is greater than 0, what does that mean? The graph is only moving up. So if you look at this graph, if this is the f graph, does it intersect currently? Yes. Intersect, still intersect. Up until this point here it won't intersect. There it will intersect once at that point, but nothing more than that. Can you see, if it's more than that value there, it can't intersect. You guys understand? So that g of x value here, this g of x graph here, this is negative 180 and 2. This is negative 180 and negative 1. So that means to say, this graph must move how many units up? It will move 1, it will lie there, and it moves further 2, it will lie on that graph. So which means to say, to get from there to there, it moved how many units? 3. Which means to say, if this graph moves anything more than 3, it will never intersect. Can you see that? So in other words, to answer this question, we have to then say, therefore, k must be greater than 3. Alright. Let's go to the next one. A 3D problem here. A surveillance camera A atop of a security building shows 2 cars parked outside the building. B. The angular elevation of A from D is theta. Of A from D is theta, which is this angle here. Car C is equidistant from car C is equidistant from the building B. They denote the distance of DC, BX, and CDB beta there. Alright, first question. So this is 8.1. Find BD in terms of X and cos 2 beta. dB. Okay, so we're looking at dB, which is the same here. Okay. So what we have is we have 2 lengths and an included angle here. We know we can calculate this angle BCD. Okay. And of course we're going to use the cos rule. Or since we've got many angles, we can actually use the sine rule as well. Okay, there's many angles, so we can use the sine rule. But let's see what we end up with. Okay. So firstly, D BC is equal to beta. Why is that beta? Because it's angles opposite equal sides. As you can see, the sides are equal here, both is x. Then BCD is equal to 180 minus 2 beta. Why? Sum of triangles. Okay. So that's 180 minus 2 beta. Alright. So now the sine rule is dB over sine 180 minus 2 beta is equal to x over sine of beta. Any one of those two. So dB is equal to, that is going to be sine 2 beta, and I cross multiply, so it's x sine 2 beta over sine beta. Okay? This is actually not what they want, because right here is 2 beta. Can you see that? So what does that mean? I must use the cos rule. I can't use the sine rule, because this will simplify into x times 2 sine x sine beta cos beta over sine beta. Where that cancels, gives you 2x cos beta. And that's not what they want. Why? Because they wanted cos 2 beta. Okay. I think I'll probably leave this later on, so I'm just going to pull it down, or maybe not, and go and use the cos rule. Okay. So just take this off again. The initial layout is still needed. So firstly, that this angle is B. So DBC is equal to beta, and BCD is equal to 180 minus 2 beta. So the cos rule is going to be dB squared is equal to the square root, no, because it's squared, that mustn't be there. So that will be x squared plus x squared minus 2 times x cos of 180 minus 2 beta. So that's going to be BD squared is equal to 2x squared minus 2x squared. Now cos 180 minus beta takes the second quadrant. Cos is negative. Changing this negative to a positive cos 2 beta. Okay? They didn't ask you for BD squared. They asked you for BD. So I'm going to take the square root both sides. I'm also taking out x squared as a common factor. 2x squared, sorry. You could have also taken out x squared, make no difference there, much of a difference. So that is going to be 1 plus cos 2 beta. And if you apply the square root, it will be x into 2 into 1 plus cos 2 beta. Okay? That's number 1. Then number 2, it says prove that so just keep this here, because I need a space. Number 2, it says prove that AB is equal to. So now you see, here's AB. Remember that stands 90 degrees to the horizontal plane. Okay? And I will definitely pick up BD. Why? Because that's a link between the two triangles. So which trigonometric function uses adjacent and opposite and adjacent? Tan. So tan of theta is equal to opposite, which is AB, over adjacent, which is BD. So I'm going to make BD the subject of the AB the subject of the formula. So AB is equal to BD tan of theta. Let's say, hang on. Here's tan of theta. Here's BD, sorry. This is what BD is equal to. So I'm going to replace that. So I'm going to now say that x root 2 into 1 plus cos 2 beta times tan theta. Alright. But if I look here, I don't have cos 2 beta. So I must replace that with one of those 3 that we had earlier on. Okay? It should be one of these 3. Did I pass it now? Yep. probably took it off. Okay, but should have been here somewhere. Because it's cos of the double angle, it's going to be either 2 cos squared beta minus 1, 1 minus 2 sine squared beta, and cos squared beta minus sine squared beta. Alright, but because there's a cos there, I'm going to choose the one dealing with cos, which is the first one. Okay? So that's going to give us x, the root of 2 into 1 plus 2 cos squared beta minus 1 times tan theta. That of course cancel. So it's x into 2 times 2 is 4 cos squared beta times tan theta. So it's x, the square root of 4 is 2. Square root of cos squared beta is beta. Tan theta, which is 2x cos beta tan theta. Okay. So just check here, is a question? Yeah. So in tomorrow's lesson, we're just going to conclude this paper. Okay? If you will enjoy the rest of your day, good afternoon class.